All right, so this is another video for chapter 6, Statistical Inference. I have got some emails from students and they're having hard time understanding the concepts. So for this kind of stuff like statistical inference, you have in general for this whole course, business analytics, you have options like either you can learn everything by heart. That is the way, like you should know everything basic, or at least you should know how to get the right answer and use the techniques and get the problem solved. So take an example of microwave. So a lot of us, we don't know how actually microwave work. So ask yourself, do you know how actually microwaves work? Like, do you know what is the science behind it? Like, how many of know while using a microwave oven for warming our food? Do you know like how the microwaves actually interact with the molecules and their movement is increased because the microwave just try to increase their um, electron movements, and due to that the food, it gets warmed, or liquid gets warmed, and it because it's actually the movement of the electrons which is increased by the frequencies of the waves of the microwave. So actually the microwave works like this, or something like this. I don't know exactly, but we don't know this, but all of us know how to use it. All of us put our food in it for a perfect time. It's perfectly warm, whatever we like, we use it as we like we are like experts in using it, but we don't know how actually it works. And a lot of time we don't care how exactly it works, but we know if you have to cook this thing, how much time we have to put, for how long, at what temperature, and everything. We are expert in that. So think about this and this business analytics course, that you know how to use things, and you don't actually care a lot like on the behind the scenes thing, how actually the microwave frequencies change the speed or the movement of the electrons. You don't really care about that part, but you just care about, you need nice cooked warm food. That's it. So our objective is similar. All right, so we have covered a lot about this in first two videos. We were in this section where we are talking about interval estimation and other stuff. So I can explain you this stuff through some examples now, because I think we have the basic foundation. And the way I'm thinking is by working on the practice problem, what we have to do. So I will show you each of the practice problem and the way how I will answer them. So it will give you a very good idea how to actually use. So I will go to my course. This is our course homepage. This is the place through which I usually get in. So once I am in Cengage, I will go to chapter number 15, or I'll just change my view. So this week we have two things, and these are both the things are due today. So we have actually three things. We also have a discussion board, and you guys should also submit your discussion by tonight. So there's a homework from chapter number 6, and then there is a quiz. So I will go over each question of the homework. So let's start the homework. All right, so let's go over this question. So for the year 2010, 33% of taxpayers with adjusted gross income between 30,000 and 60,000 itemized deduction for their federal income tax return. the mean amount of deductions for this population of taxpayers was 16,000. So the mean deduction or the mean amount is $16,642. Assume the standard deviation, which is mu, is 2,200. So everything they're talking about here is population. So this is population mean. So it's an estimate, or it's the actual population mean, and the standard deviation is for the population. So we have given population mean and population standard deviation. All right, so we know this. But how about if we take some samples of the data and see how their mean and standard deviation comes out? So this question is, in this question, they're asking us to make a sampling distribution. So we have this mean for the whole population and this standard deviation for the whole population. So mean is the average amount, and the standard deviation is how much each person is away from the average. How much each person is away. So on average, each person is away 2,200 from the average. Some people will be actually on average. They will be exactly to this amount, but some people will be above and some people will be far lower. So, but on average, they deviate from the mean by $2,200. All right, so we have this information. So what we have to find is what are the sampling distribution of X bar for itemized deductions for this population of taxpayer for each of the following sample sizes: 30, 50, 100, and 400. So there are different sample sizes, and we have to find expected value of the sampling distribution of X bar, and we have to find standard deviation of the X bar. So if you guys have seen my video, I've talked about that X bar is like, we can take one sample. If there are like millions of people, like 33% of taxpayer is still maybe millions of taxpayers. So if we take 30, that would be one sample. If we take 50, that would be another sample. 100, that would be another sample. We can take as many samples as we want just to get a better estimate. So to get a fair estimate or better estimate, we can take different samples, and all of those samples will have different means and standard deviations depending on the size of that sample. So one of them, like if I take any sample, sample size of 30, 50, or 100, 400, I can find the mean. And the interesting part about the mean of the mean, so if I take a sample of 30 people, take a mean, and take their mean, and then another sample, take their mean, and I take like hundreds of samples like this and get the means of each sample, and then take an average of all the means, it will be an unbiased estimate. It will be exactly same to this one. All right. So the point here, they're asking us, they're saying, what is the expected value of the sampling distribution of X? Or what is the expected value of X bar? So expected is also a mean, and X bar is itself a mean. So we are trying to take means of means. And we know that from our discussion in the last video that the expected value of X bar is actually unbiased estimator of population mean. It's just the same thing. And so here, I want to show you in this chapter. So here they're talking about sampling distribution of X bar. And here they're saying, okay, the expected value of X bar is actually the population mean, which is $66,642. So I will enter this value here. Next, we are asked to find out the standard deviation of the X bar. So standard deviation of the X bar is not an unbiased sample. There is a biasness, and each sample has a different kind of a standard deviation from the actual standard deviation. And we have the formula for that one too. So here, if you can see, sampling distribution. So this is a sampling distribution, and sampling distribution, the expected value is equal to mu, and the standard deviation of X bar has two formulas. So for finite population and for infinite population. So here we are not given the population size. So we don't know what is the total population. We know what is the sample size. So we don't know the total size of population. So we cannot use this formula. We have to use this one, in which we have the standard deviation of the population and the sample size. So here we have to find out for each population the sample size. Now, some students usually ask me, okay, I have put that in the final exam or in the first exam that you have to submit an Excel sheet. And then some student asked me, they don't have anything to show on Excel sheet. Well, you can actually, the right way to do any exam or these assignments, so I'll just put them maybe side by side. So here is this part, and then this comes my Excel sheet. So this is my question number 1. You guys should do the same thing for your exams. So question number 1, I have to find out mean standard deviation using different sample size. So, and I have 30, I have 50, I have 100, and I have 400. I have to find sigma X bar. I'm just putting here sigma X bar, easy. And the formula to find the sigma X bar is actually this one. Here we have this formula, sigma over under root n. So sigma, why don't we also put here somewhere sigma? So this is mu, which is actually equals to what, 16,642, and sigma means the population standard deviation is actually 2,200. All right, so pretty easy now. Our work has become much easier. So we have all the values here, sigma, mu, and what we have to find the sample X bar on each sample size. All right, so I'll put here this value divide by this value. And secondly, I can make this as absolute. So now if I drag this down, this will become constant, so it will not go down. And oh, I actually took a wrong value. I should be taking a mu value. So I took a mu value, but I should be taking sigma value. So sigma over under root n. So I put under root only n. So I have to put here SQRT, which is square root of n. And this comes out 401. All right, so this comes out F2. All right, so there's F2, which is sigma, over SQRT n, which is 30. And I can actually drag all of them down and go back to my question again. All right, so now I have all the figures. So they're saying if required, round your answers to 2 decimal places. So I will actually select this and do the rounding to 2 decimal. So I can use this option. This will just make my life easier. I can just round it from here. So the first one is 401.66. The second one is 311.13. Oops, sorry. All right, so this is our sample standard deviation based on the sample size. What is the advantage of a larger sample size when attempting to estimate the population mean? A larger sample size reduces the standard error, because I can see this. This is also called standard error. So we can see the error. It was like on average, our error or the standard deviation between the sample averages is 401. And if we increase it to 400, we can say that the on average, the 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 error between the averages, like how they are far from the actual average, is 110. So this reduces the standard error and result in a more precise estimate of the population mean. So and result in a more precise estimate of the population mean. So this is our answers. All right, so great. So all of them, these are the answers. So this is how you have to answer this type of question. So we're done with question one. Let's go to question number two. So in the second question, we are given a situation where health insurance are beginning to offer telemedicine services online that replace the common office visit. WellPoint provides a video service that allows subscribers to connect with a physician online and receive prescribed treatments. WellPoint claims that users of its Live Health online service serves a significant amount of money on a typical visit. Okay, so the data shows here, data given below, we have given this data file for 20 online doctor visits are consistent with savings per visit reported by the WellPoint. This is our data. 20 online doctor visits, and the savings for each of them have been given here. So this must be 20 in total. Assuming that the population is roughly symmetric. So the population is actually symmetric. And we have to construct a confidence interval for the mean savings for the televisit to a doctor as opposed to an office visit. If required, round your answers. So we have to find the confidence interval with 95% confidence interval, that the mean will be within here. In here, when we talk about, so technically we have to talk about, I'll just stop this video and probably start again a different video, because this is, I get a message here. And I will upload this video, and then I will upload a second video. So I'm suspecting that I have a break in internet, so my recording would have been stopped. So I will start again a new recording file. So look for a second part of this video.